Dear viewers, welcome to another video on control charts. In this series of control chart videos, we have seen control charts for variable data, where we have seen IMR chart, X bar R chart and X bar S chart. We have also seen control charts for attribute data, where we have seen proportion chart, P chart, and number of defectives, NP chart for defective category. In defects category, we have seen U chart, which is defects per unit, which is our previous video. And in this video, we are going to understand about C chart, count of defects. So how C chart is different from U chart and how to plot the C chart, all these things we can see as part of this video. Let's get into the video. As I was explaining, there's a small difference between U chart and C chart. First, let me explain the difference, then let me take you to the sample data that we have. What is a U chart? So in the previous video, I have given an example of in a e-publishing company, on a given day, they took 30 sample pages and in that they counted the number of spelling mistakes in the words, and based on that, in one column you have samples for the subgroup, another column you have defects for the subgroup. Based on that, you will be able to calculate defects per unit. That means for every page processed by the e-publishing company, how many possible spelling mistakes that they can have, which is defects per unit, which is a computed value for a given sample size for a given subgroup. Whereas the scenario that I am going to talk about in an electric scooter manufacturing company, when a scooter get manufactured, for a given scooter they do a visual inspection. For every serial number of the scooter, unique serial number, they do an inspection. So once the inspection is completed, how many defects have been identified in that particular scooter get documented in a Excel file. So in the previous scenario of e-publishing, it is a summarized computed value, whereas in this scenario, for every unit, the number of defects have been counted and collected in a data collection sheet. So in this scenario, we need to go for C chart, defects for every sample that we inspect. If we want to give a graphical representation, we need to go for C chart, right? Okay, so now let's get into the data and understand this data. So here in column A, I have the serial number of the electric scooters. So this is an electric scooter manufacturing company where serial number is a unique number for every scooter that is getting produced. So that serial number is there in column A. And in column B, after the visual inspection, how many defects have been identified as part of the visual inspection? That data is in column B. So what do we mean by this? People inspect the vehicle. If there is a scratch mark, dent mark, screw missing, cable unplugged, all these kind of things have been identified during the visual inspection, and that visual inspection count for each vehicle is documented in this. So what you see here is number of defects for this particular vehicle, number of defects for this particular vehicle. And for us to draw the C chart, we need to calculate the central line, which is your C bar, then your upper control limit and lower control limit. The formula for central line is C bar. So C bar is nothing but average of the count of defects that we have identified. And the formula is very simple. We know count of that is sum of all data points divided by count of all data points, we will get the average. And this is going to be our central line. So I am referring this line for all the cells in my table. And once I have done this, now I need to calculate my upper and lower control limit. So the formula is very simple and straightforward in the case of C chart. So your upper control limit is C bar plus 3 times of square root of C bar. So I have my C bar value here. So I select C bar plus 3 times of square root of C bar, and I close my bracket. So I now hit enter. So I get my upper control limit value. Now for lower control limit, exactly the same formula. Instead of C bar plus 3 times of square root, we have to use C bar minus 3 times of square root. And as always, when we are using the formula for lower control limit, we need to add one more function, and that is it, in case if your value is less than 0, if it is a negative, still you need to have your lower control limit as 0 only. So we use the max function of Excel, and max of either 0 or the value that we are computing. So now I close this. So these are my upper and lower control limits. So now I can say, or I can refer these values, and I can take it to all the cells in my table. So now I have my individual defects per unit that is being inspected, or individual unit for every single individual defect for every single unit that is inspected, and C bar, UCL and LCL for the C bar. Now I can select these values. I can click on insert, and I can click on graph, and I can select this graph. So we can rename this graph as C chart. So as you see here, this is the C chart. So friends, what we can do is we can take this data, just this data alone, to Minitab, paste it here, and now we will see how the same chart can be constructed in Minitab. I can click on stats, I can click on basic stats, stats, control charts, and in control charts I can select control chart for attribute data, and in attribute data I can select C chart. C chart is count of defects. So I select this defects count. I don't have to select any other option because this is defect for every unit that is getting inspected. So there is no need for us to define the sample size. In all our previous formulas, sample size played a very important role in the calculation of upper and lower control limit, whereas in C chart, sample size do not play any role because there is nothing called sample. It is defect for every single unit that is getting inspected. So I can click on C chart options. I can go to test. I can have the Poisson distribution test that need to be checked. Now I can click OK. Again I can click OK. I get exactly the same chart that got created in our Excel file. Let me copy it and paste it closer to this so that we get a better view. So here you see, this is the same chart that we have constructed using Minitab. So let me quickly summarize this chart for you friends. So this chart is drawn for discrete count data which follows Poisson distribution, and the nature of the data will be defects, number of, count of defects. So that's how the nature of data will be, and how we need to collect the data for every sample that is being inspected, or for every unit that is being inspected. The defects are computed and are counted and documented in a data collection sheet, and from there we calculate the C bar, which is nothing but average of count of defects, and from there we calculate our upper and lower control limit, which is C bar plus 3 times of square root of C bar, and C bar minus 3 times of square root of C bar. As we do it, we will be able to get the upper and lower control limits, and with this we will be able to plot our C chart, which is a control chart for attribute data following defects, or in other words, Poisson distribution. So friends, I hope this video was useful for you to understand about C chart, how to draw it in Excel, what is the formula to calculate center line, upper control limit and lower control limit, and how the same chart can also be drawn in Minitab. So this video would have been helped to you. For more videos on control charts, quality management tools, Minitab tools and techniques, please subscribe to our channel. Thank you.